Greetings panel. This is our group for capstone project. The topic for our project is the automated intelligence gathering and analysis system. My name is Rudran Sharoda. I am from ENC branch.
My name is Nitin Menon and I am from ENC branch.
My name is Amit Kumar Singh and I am from ENC branch.
My name is Nandishwara and I'm from ENC branch.
My name is Harsh Kumar and I am from ENC branch.
So now we are going to look at friend and foe detection using LORA. LORA, as we know, is a physical radio communication technique based on spread spectrum modulation technique derived from chip spread spectrum, that is CSS technology. It offers advantages such as long range and low power consumption, and that is why we are going to use it in our project. In our project, we have divided it into two segments for friend and foe detection. That is, first, LORA, that will act as transmitter module. It has sensor module which will collect relevant data for friend and foe detection, a microcontroller which will process or analyze data, LORA transceiver that will transmit data using specific frequency. In our case, it will be 433 megahertz. Encryption module that will secure the transmitted data, and authentication module that will authenticate the technique and will secure the data. LORA as a receiver module, LORA transceiver. It will receive and demodulate incoming signals at specified frequency, which was 433 megahertz. It contains signal processing units that will filter and analyze the received data. It also has ML learning modules, which will classify signals as friend and foe based on processed data. It also has a user interface, which will obviously display the results and the alerts, if any. Power management, it will manage the energy consumption and sleep modes. Now we look at the demonstration. For example, here we have four tanks. Tank A, Tank B, and Tank C are the enemy tanks, and Tank X, Tank Y, Tank Z are the friend tanks. The three tanks, that is Tank X, Y, and Z, they are fitted with the LORA, that is the transmitter module, and these are going to send the signals through sensor modules and microcontroller, and there will be a control room where there will be LORA which will act as a receiver module, and that will receive and demodulates the signals, which will basically confirm whether these tanks belongs to us or the enemies.
Greetings, sir. So this will be the demonstration video of my project of implementing a secure communication channel between a drone and a control center. So currently there are two terminals visible on the screen. The one on the right side is the client terminal or the control center, and one on the bottom left is the server terminal or the drone. So we will be sending commands from the client to the server. The server will receive the commands and perform the necessary action and give back the response back to the client. So I'll just show a bit of it. First I'll start the server script. Now the server is waiting for the connection to establish from the client. Once the connection is established, we will be sending commands. Now I'll run the client script. Now as you can see, we can input the command and the current position of the drone is also visible. And on the server side, we can see that it is showing that the signature is valid. So now we will check the different commands. I'll run the server script, client script. So now I'll give the command. Now it is showing that the command is takeoff. The response is acknowledgement response, and that the drone has taken off to the height of 5 meters and the current position. Now I'll just give a series of commands. I'll give the angle as minus 90 degree because if I'll give the 90 degree, drone will rotate about anti-clockwise. I want it to rotate around clockwise. Now I'll rotate the drone 180 degree. Now I'll just move backward again. Now if I give the comeback command, I get these positions. It tells the shortest path. Now we see that the drone has traveled to the position minus 5, 5, 5, but in the comeback path, it is not going towards that position. I'll give some other commands also. Now since we have given the comeback command, the drone is back to its original position, that is the origin. I'll give some other commands also, just to check the credibility of the comeback command. We'll give the comeback command. Now we see that the optimal path is shown here. We'll try one more example. Now, since we have reached the origin already, I'll give some more commands to check if the comeback command is working fine or not. So, move upward. Now I'll give the comeback command. Now we see that we are getting the optimal comeback command. Now if we want to close the connection, I'll just write quit. So that was the demonstration video for the project. Thank you.